So yesterday we started surface area. Actually, it wasn't yesterday, it was the day before yesterday. We started surface area of prisms on Monday. Today we're going to continue that lesson. This is part B, and we're going to do that by doing cylinders, which are super similar to prisms. They're just as difficult. I don't want to scare you, but they're kind of tough, just like prisms were. But the goal or the objective for the next 3 days in my room is going to be to learn to find the surface area of a cylinder and at least feel a little bit confident in doing it. So the formula that we're going to be using, I'll just jump to it over here, it's this one right here, is surface area is going to be 2 times pi radius squared plus 2 pi radius height. And I feel like this is just a bunch of junk to think about. So I kind of want to really quickly show you how we come up with that formula. If you remember, with the surface area for a prism, we did the area 2 times the area of the base, which is going to account for our bases. And then we did plus the lateral area, which is all of this, times our height. So we're going to do the exact same thing, but we have to do it in terms of pi, because lateral area for our prism was actually called perimeter times height. So first, back to the base though. So if we have 2 of these, and how do you find the area of a circle? You find it by doing pi r squared. So that's where they get the first part of this formula, 2 pi r squared. And then for the next part, where we have the perimeter, to find the perimeter of a circle, it's the same thing as circumference. So we want to write the formula for finding the circumference of a circle, or the perimeter of a circle, which is 2 pi r. And then we're going to multiply that times our height. So that's where they get the 2 pi r times height on this part of the equation. So you might have to watch that a couple more times, maybe 15 more times. At some point though, I hope it kind of clicks a little bit and you can kind of see where they pulled these numbers from. If not, to start off with, just take your formula, plug your numbers in, and calculate away. So let's start with an example. We're going to find the surface area to the nearest tenth, so 1 decimal place. And we're going to make sure we use our pi button on the calculator. So first we have to start off by finding the area of our base. Our B is pi radius squared. And the radius that we have for this example is 4. So pi times 4 squared is equal to 16 pi. And then if you wanted to do perimeter, or what we're going to call circumference, because we're doing a circle, we'll do 2 pi r. So if our radius is 4, we get 2 times 4, which is 8 pi. And then our height is just given to us, it's 6 inches. So now we can go back to our formula and substitute in. So if our base was 16 pi, plus our perimeter, or a circumference of 8 pi, and then times our height of 6. So that will be our numbers that we need to start calculating with. So now we just need to do some simplifying. So 2 times 16 gives us 32 pi. And then over here we have 8 times 6, which is going to give us 48 pi. So we're going to add those two together and we get a total of 80 pi. And now we have to use our calculator. So we're going to do 80 times our pi button, and we want to round that to the first decimal place. So I get 251.3, and this is in inches, and because it's just surface area, area is only squared. Okay, number 2 is going to be your first you do, and I feel like we're jumping into it pretty quickly, but this is the first you do on your own. I will get you started though. I'll show you that your radius is 15 for this example. So if you simply do it by plugging numbers, it shouldn't be too hard. You're going to have two of your bases, which are pi r squared, so r being 15, this is 15 squared, plus you need your circumference of 2 pi times your radius of 15. And finally, you're going to multiply times that height of 3 centimeters. So you're just going to start multiplying things out, simplifying, starting with exponents, and work from there. And when you get your answer, have me check it to see if you're doing things correctly. The next two problems are kind of application problems where we're going to apply them to something in the real world. So the first one talks about a cylindrical soup can, also meaning like a soup can shaped like a cylinder. And it's telling us that the top of the soup can, the diameter, is 7.6. So the whole line across is 7.6 centimeters. And that the height of the cylinder is 11.2. So we want to know what the area of the label is. If we want the label, it's going to be like the label that wraps around the outside, but it's not going to include these bases. So these bases are not going to be included. The base that's down here, up there. So back to our original formula. So back in our original equation, this entire piece right here is to find the area of these bases. If we don't need those, we don't have to do this part of the problem. So our new formula that we're going to use is just the last half. So this one shouldn't have as much calculation, which is kind of nice. The only other problem I see is that over here, 7.6 is representing our diameter. But in order to solve this problem, we don't need diameter, we need radius. So radius, remember, is just half of your diameter. So 7.6 divided by 2 is going to give us a radius, which is a radius of, 3.8. So we're ready to start substituting over in our formula. So we've got 2, bring down pi. R we can substitute in with a 3.8. And I like to do different colors just so you can see which pieces. So that came from there. Times our height, which our height was 11.2. So let's do some simplifying. I know that 2 times 3.8 is 7.6. And now I can simplify by multiplying 7.6 times 11.2, which gives me 85.12 pi, which is already kind of a weird answer, but I'm going to now take 85.12 and put it into the calculator using the pi button times pi, and I get a total of 267 point, rounded to 4 centimeters, and it's going to be square centimeters because we're just doing area. Okay, this is the last problem that we're going to do together, and then you're going to have two that are just basic cylinder surface area problems to try on your own. So this one says a cylinder storage tank has a 6-foot diameter. Oops, I ran off the page. So all the way across is 6. And then it's 12 feet tall. So it goes on to say that it needs to be painted and that the paint will cover 100 square feet for every gallon of paint that we buy. This is information that we're going to want to save for just a minute, because first we need to figure out the surface area so we know how much surface needs to be painted. So to do that, we're going to need our equation. So far I have everything I need except one thing, and that's that I have diameter is equal to 6, but I need my radius, so it's just half of 6, which is going to be 3. So now we can start substituting. So 2 times pi, and then our radius is equal to 3 squared We're going to do plus 2 pi. Our radius was 3, and our height was 12. So now I'm going to do some simplifying. I know that 3 times 3 is 9. 3 times 12 is 36. 9 times 2 is 18 pi. And then 2 times 36 is 72 pi. So now I'm going to combine 18 plus 72 for a grand total of 90 pi. And when I multiply 90 times the pi button and round, I get 282.7 feet. Square feet. So I have a total of 282.7 feet, square feet of surface that need to be painted. Now I can go back to my problem where they're telling us that we need to shop for paint. The paint's going to cover 100 square feet per gallon. So if we bought one bucket, we will still have 182.7 feet left. If we buy 2 buckets, we're going to have 82.7 cubic feet left to paint. So we're going to need one more additional gallon. We won't use the whole thing. But that is the number of gallons we would need to buy. Okay, for your last two, you're going to go ahead and try these on your own. Go ahead and just use your formula. S equals 2 of pi r squared plus your perimeter, which is 2 pi r, times your height. And you're going to use that for both of these problems. So they're pretty straightforward, and make sure you have me check them so that you can see if you're doing it correctly and so that you can get credit for doing what you are supposed to be doing today. Good luck, guys. Please, please, please let me know if you have any questions. I'm here to help you out. Good luck.